Welcome everyone, and thank you so much for joining us this afternoon to create beautiful data visualizations in R, a ggplot2 crash course. This useR tutorial is co-hosted by Our Ladies New York City and Our Ladies DC, and we're thrilled to have you here today. So my name is Emily Dodwell. I'm a principal inventive scientist in the Data Science and AI Research Organization at AT&T Labs. And I'll be one of the TAs today, along with, we have Kathleen Wendt, Ludmila Yanda, and Gwen Sturdivant is our Zoom moderator. So I'll give a quick intro to each of those people and then introduce our fantastic tutorial host for today. So Gwen Sturdivant is looking for new opportunities in analytics. She previously worked at Volano, where she was doing analytical projects in the rail and aviation sectors, including development of prediction algorithms and methods to produce unbiased algorithmic results. Kathleen Wendt is a graduate student and National Science Foundation Graduate Research Fellow in the Department of Human Development and Family Studies at Colorado State University. Kathleen is co-developing open source curricula in R programming and data scientists, as well as a suite of R packages. Ludmila Yanda is a data scientist at Amplify, which is an education curriculum and assessment company. And her work provides insights on student and teacher usage, student success, and Amplify's broader impact. As for myself, as I mentioned, I work at AT&T Labs, and I work on predictive modeling for advertising applications, the creation of interactive tools for data analysis and visualization, and research concerning ethics and fairness in machine learning. I would also like to give a big thank you to Kaylin Medeiros, who handled all of our registration setup for today. And so now an introduction to Dr. Sam Tyner, the woman of the 2 hours here. So Sam Tyner is a statistician and data scientist who is passionate about data visualization in R. She has been using ggplot2 since version 0.9.2 in 2012, and she co-authored the ggplot2 extension package, GeoMNet. Dr. Tyner has taught ggplot2 to undergraduate students, graduate students, and professionals, and she earned her PhD in statistics from Iowa State University in 2017 under Dr. Heike Hoffman. Currently, she is a Science and Technology Policy Fellow at the U.S. Bureau of Labor Statistics, though she is seeking a new role where she can flex her data visualization skills. So Sam, I'll turn it over to you. Also, did I pronounce that package correctly? Oh, great. Okay. It's
Yes.
all you, Sam.
Okay, great. Thank you so much, Emily, and thank you all for coming here today. I'm really, really excited to be presenting this material to you today. So first off, I wanted to get started with a few logistics, what we're going to do today. So here's just a few tips on how to watch this webinar. So for optimum learning for yourself, the best way to participate and to learn is to have both the webinar software and the rstudio.cloud window visible at all times. And that rstudio.cloud project was sent to you in the Google Doc to your email. And you can also follow along with the code once you get into the project. So I'll sort of open that up here for you and show you how that works. So what you're going to do is you go to the RStudio Cloud window here. And so you can see I've clicked on the link and I've opened this up in another account so that it's saying temporary project here. So what you're going to want to do is you're going to want to click on save a permanent copy. So then that way this is now in your account and you have it forever for yourself. And so the easiest way to participate in the tutorial today is to work in this R window, and you can go ahead and go into code and you can go to follow along, and that's going to be all the code you're going to need today. You can also go to slides and open up slides.rmd to follow along if you want to as well. So yeah, anything that you have in this window is now going to be saved to your account. And so what we're going to do, if you want to download it to your own computer after the fact, what you can do is you can go ahead and export it. You can go to Cloud, Project, More, and then you can export the whole folder. So you can have all the RStudio information there in your own computer. Okay, so I'm going to go back to the slides now. I'm seeing a lot of chat activity, so I'm just going to double check, make sure there's nothing I need to do. Okay. So it looks like the link is in the chat for the RStudio Cloud project, so that's good. Let me just double check. Okay, yep, that looks good. And actually, I'm going to paste in my link as well, because I'm not sure that the one that's being pasted in is the correct one. That might be everybody's individualized link. Okay, so I'm going to go ahead and let's see. Finally, one final point here. After accessing the course material, I'm going to give everybody some time to do that, but just an FYI, the TA structure here, so the TAs are going to be the ones answering your questions. Do try to put your questions in the Q&A portion of the Zoom that should be on the bottom of your screen, sort of on the right-hand side. You should see a Q&A button, so please put all your questions there. The three TAs, Kathleen, Lamilla, and Emily, will all be answering your questions sort of on the fly. And then if there's a question that I need to answer, they will let me know separately. And finally, we have a Zoom moderator, which is Gwen. So Gwen is going to be monitoring the chat and just sort of making sure that everyone's on their best behavior. Just a reminder that we do have a code of conduct for useR 2020. And so the Zoom moderator has full discretion to adjust the code of conduct for virtual conference events, and she can remove participants as well. So just a note of that, just to be on your best behavior, which I'm sure you all are.
You can just message the panelists if anything happens that, you know, where you don't feel uncomfortable, where you feel a little uncomfortable. We're here to help, and we really want this to be a safe environment for everyone.
Yeah, everybody, yeah, good point, Gwen. Thank you. Please message Gwen if you have any difficulties with your attendance. Okay, so with that, I think I'm going to go back to my slides here. So finally, the most important thing to do is to have fun, and that's how you're going to be successful during this webinar. So what you're going to get out of today, hopefully you will be able to do 5 things once you leave this tutorial today. First, you're going to be able to identify appropriate plot types and corresponding geomes to use to consider when visualizing your data. You're going to be able to implement the grammar of graphics and build up plots with the plus operator and the ggplot2 or the ggplot function. You're also going to be able to iterate through multiple visualizations of your data by changing the aesthetic mappings, geometries, and other graph properties. You will be able to incorporate custom elements such as different colors and fonts and so on into your visualizations by adjusting theme elements. And finally, you'll be able to investigate the world of ggplot2 independently to expand upon your skills learned in the course. So the goal of this course is to give you a really solid foundation to build up from. So first we have a motivating example for you today. And so I'm going to try and play this YouTube video, and it's not working. So that sort of was expected to happen. So I'm going to go over to YouTube and we're going to watch this clip together.
Yeah, Santiago, settle a little tiff that Kevin and I are having.
Let's be honest, Raymond, it's not a tiff, it's a row.
And now it's a scene.
It's okay, sir. We don't want to get involved in your personal life.
It's not personal, it's a math problem.
Pass.
Raymond and I had dinner together last night for the first time in 2 weeks, thanks to the night shift.
And Kevin thought it would be fun to spoil our date with an inane math problem, to which his answer is wrong.
Enough foreplay, let's get to the numbers.
It's the Monty Hall problem. Imagine you're on a game show. There are 3 doors, behind one of which is a car.
You're telling it wrong. There are 3 doors, behind one of which is a car. You pick a door. The host, who knows where the car is, opens a different door, showing you there's nothing behind it. Now the host asks if you'd like to choose the other unopened door. You do it.
No.
Yes.
It's simple math. It doesn't make any sense to switch. The prize is behind one of 2 doors. It's a 50-50 chance either way.
It's 2/3 if you switch, 1/3 if you don't. The probability locks in when you make the choice. We've been over this 8 times.
7 times. Now you can't even do simple addition.
Kevin is right.
You're fired.
What?
Okay, so what was going on in that scene from one of my favorite shows, Brooklyn Nine-Nine, is the Monty Hall problem. And so the Monty Hall problem is sort of this famous, unintuitive math and probability problem that people like to get in fights over. And clearly in that situation, you had a couple of spouses arguing over what was the right answer. So what if instead of having an argument, we could write an R file that would run the Monty Hall problem 100 times, and it would show you exactly what would happen, you know, by chance if you switch the doors or if you don't switch the doors. So here again, here's the situation. You have 3 doors, you pick a door, and then the host shows you a door where there's not a prize, and then it's should you switch or should you not switch. And so what we're going to do now is I'm going to show you a visualization that I made using ggplot2 and the ggplot2 extension package ggAnimate to sort of show the solution to this problem. So that way you don't have to fight with your spouse about it. So what you're seeing here is 100 simulations of the Monty Hall problem. And in the blue, you see every time they win. And then in the yellow, you see every time they lose. So here you can see clearly that Kevin was correct, that in fact, the probability of winning when you switch is 2/3, and the probability of winning when you don't switch is only 1/3. And so now that we have this visual, how can we make this in ggplot2? So this is sort of something to keep in the back of your mind throughout, and eventually you will make this on your own. So first, we're going to talk about ggplot2 and the grammar of graphics. And I just want to shout out Allison Horst, who is an excellent artist and data scientist, and she's made several really cute illustrations for our studio. And I like to pepper them throughout my talks. So this first one is about ggplot2. And so this first part will start off with a little bit of the theory of ggplot2 and the grammar of graphics. So the grammar of graphics comes from a book by Leland Wilkinson in 1999. And so if you recall from your elementary school days, grammar is the study of classes of words, their inflections, their functions, and relations in the sentence, okay? So that's sort of the language approach, whereas it can also be the principles or rules of an art, science, or technique. And so that's the approach that that's the definition of grammar we're using for the grammar of graphics. So this is going to be a set of principles for constructing data visualizations. And if you're familiar with this simile structure here, so you have the grammar of language is to a sentence, as the grammar of graphics is to a data visualization. And note here that I'm going to try to use data visualization instead of terms like plot or chart or graph, because it's a more precise term. So just note that in advance. So we know grammar really, really well, right? We all speak a native language, and all languages have a grammar. So we know how that works. So now how can we apply that to data visualization? So here's a simpler version of, here's a static version of the plot that we saw initially. And so you can see here we have 2 bars showing the percentages, and then we have the 2 outcomes, and we have one graph for switching and one graph for not switching. So how can we recreate this simple static graph in ggplot2? So we're going to connect this, each step of this, we're going to connect back to the grammar. So if you think about grammar in the language, you have nouns, which are the person, places, and things, right? Those are sort of the most important pieces of your sentence. That's what you're talking about. And so here, when you make a data visualization, what you're talking about, what you're demonstrating is the data. So we have the data on the right-hand side here. And now we build it up into our code. So what I'm doing is I'm going to read in the data using the read_CSV function from the readR package. Then I'm going to library ggplot2 so that I have those functions available to me. And then I'm going to call the ggplot function, and I'm going to pass to the data argument the data mh_sims, which I just read in, which contains the data that I need to create this Monty Hall visualization. So what you can see here, when I pass in this code and I run it, I just get a blank space. So sort of think of this as your canvas that you're going to draw your plot on top of. Okay, the next bit is the geom, or the verb So the verb is the action. This is, you know, what the noun is doing in the sentence. And so here the verb is the geom, and in this graph on the left, we have a bar chart or a column chart. And so we're going to use the geom underscore call for column function. And so we go to our code and we try to do that. So we try to add geom call, and we're always going to be adding, when we're creating a ggplot, we're always going to be adding function calls together. And we see we get an error. So it says, oh, geom call requires the following missing aesthetics, X and Y. So we know we're missing some information in the function that we're not providing. So we'll get there in a second. Just note that the geom suite of function can take many different arguments, which vary by the geom type. So you can have points, text, bars, raster, which are little squares, area, path, polygon, line, and I think there's many more than that. That's just how many I could get to fit on the screen. And if you can see more in the ggplot2 book. But so just keep in mind that when you adjust the geom, the arguments which you're going to pass into it are going to change. So the next thing we need is the AES, or aesthetic mappings. So these are acting sort of like the pronouns of your sentence. So a pronoun is used in place of a noun or a noun phrase to avoid repetition. And same thing here, we're using the AES mapping to replace the data, so we don't have to keep typing the data over and over again. So here on the x-axis, we have the outcome, which is win or lose. And on the y-axis, we have the percentage of outcomes in the group. And then we're using the fill color, we're coloring the bars by their outcome as well. And so we can do that in ggplot code. So we're using the AES function inside of ggplot, and you can also use that inside of geom call. So in a ggplot2 plot, there's always at least two ways to do stuff for the most part. So you can sort of pick and choose. I like to put my AES calls in my ggplot function call. So I'm using this AES function and I'm telling it, okay, on the x-axis, I need you to put the outcome, the win variable, and on the y-axis, I want you to put the percentage variable, and I want you to color the bars according to the win variable. And then I add geom call, and now I get a plot. So we're still missing some information here, right? We don't yet have the switch information incorporated yet, but now we have something that sort of resembles what we were expecting. And just to note that the aesthetic values, the AES values, do not have to be connected to data, and you can change an aesthetic value for the entire plot. So if you wanted to make both bars this blue color, you can just call it fill equals the hex color code is what I've done here, and you can plop that in geom call without putting it inside of the AES function. So now it's applied to everything instead of applied according to a variable. Okay, the next bit is the stat. So that's the sort of underlying the computing what's going on underneath. And so we have that sort of as the adverb, which is modifying the verb. So the stat goes with the geom, and you can kind of modify the geom with the stat and vice versa. So here we're not altering the data in any way, and so the stat is going to be the identity. And so we just have a function call to stat underscore identity, and we need to tell it which geom we're using now. So it'll say we want to use the call geom with stat identity, and this is what we get. So it's just a different way to make the same plot. The next bit is the theme. So the theme is sort of like the adjectives, right? Those are sort of describing, modifying, giving a little bit, more flavor to your sentence. And the theme is doing the same thing here. So we have the default ggplot2 theme has this gray background. It has a particular font, has a particular amount of grid lines in the back and things like that. So we're going to alter those so that it looks more like our graph on the left here. So something we want to do is we want to make the background white. We want to get rid of the grid lines. We want to change the text, and we want to change the font, the size, and how bold it is, basically. So we're going to do that. But first, what we're going to do is we're going to use this handy little trick to sort of make our lives easier so that we're typing less code. So we have here an object P, which has been assigned to be this ggplot, which we made a few slides back. And so this is a pretty common trick, and you create this object, and you can then use the plus operator with this object P to build up onto that. So we'll do that on the next slide. And so we see here now we have P, and now we're going to add some stuff to P. So the theme functions, they have some built-in, ggplot2 has some built-in theme functions. Theme gray, which is the default here all the way on the left of the screen. Theme underscore BW is a simpler black and white theme. And then you have a dark theme and so on. There's also a theme void, which just completely removes every theme element pretty much. And then there's the theme function, which is going to allow you to overwrite certain elements in the default theme. So I'm going to use the theme BW here, and I'm going to change the text because I had a different font. So I'm changing it to a serif family, and I'm making the font a little bit bigger. So that will now be applied to all of the text in my ggplot. And then I'm going to get rid of the grid element. So all these grid lines in the background, I don't want to have those. So now I'm setting that panel.grid to element blank. And we'll go on to more theme elements later on in the tutorial. And so finally, that's the result of the theme elements. So you can see here, I don't have any more of those grid lines. I've got a nice white background. My font is a little bit bigger and easier to read. And you can see it looks a little bit fancier, right? It's that serif font as opposed to, you know, Helvetica or whatever the default is. So the next piece are the guides. And these are sort of like the prepositions. So a preposition is sort of showing the relationship of a noun or a pronoun to other pieces of the sentence, right? And so a legend does the same thing. It relates your aesthetic values to the data. And so here there is no guide, and we don't need one because color, so the color of the bars and the x-axis are identical. So we don't need to also differentiate between the colors by using a legend, so we just remove it. And so here we do that with the ggplot2 guides function, and this is going to control all of your legends for you. So guides, you pass it the name of the aesthetic. So we're using the fill aesthetic equals none, and that's going to remove that for us. And notice too that we're also continuing to build up our ggplot, and so now we're on to P3. This is sort of my basic, what I do when I make a ggplot is I just keep saying P, P2, P3, P4, so on. Saves on typing time. The next bit is faceting. So this is how we're going to get these two groups based on the switch variable. And so the sort of grammar connection here is conjunctions. So a conjunction is joining two words, ideas, or phrases together and sort of shows how they're connected. And facets are doing the same thing, right? We have data in different groups and we're placing them side by side so that we can see and compare and contrast between them. So for ggplot2 code, we're going to use the facet grid function. And the grid, it lays it out in a grid like rows and columns. And so we want side by side. So we want there to be two columns. So we're going to use the COL's argument, and then we're going to use tidy syntax. If you're familiar with dplyr, this is a dplyr function just to call on the variables. So the variable switch is what we're going to need. And you can see here that now P4 has two charts, one for no and one for yes on the switching. And again, we'll talk more about faceting later on. This is just to give you a taste. There's a lot of other grammar elements that go, you know, both in language grammar and in the ggplot2 grammar of graphics. One of the ggplot2 ones is scales. These are going to control how data are translated into visual properties. So how am I going to take those like binary bits of numbers and convert them into a visual property. How am I going to do that? That's the scales. And so the analog of this is sentence structure to grammar. How am I constructing my sentences? Next is going to be the coordinate system. So this is how are we positioning our data in a 2D data visualization. So this can be thought of like the verb tense. Are we, we're just slightly changing the flavor of things to have a slightly different meaning. And then the position is the last ggplot element. And this is how we're going to deal with any overlap of points if we have any. So this can be thought of as word order, right? You want to make sure that you're showing the data in the correct order, and you want to make sure that you're speaking your sentences and writing your sentences in the correct order. And some things to know about these types of grammar elements is, native speakers don't have to think about these too much. And the analog for that in ggplot2 is that it has really smart defaults. And so you have a lot less work to do. So you don't have to construct the Cartesian coordinate system. ggplot2 has already done that for you. You don't have to deal with overlapping box plots. ggplot2 can do that for you. And a lot of these are also largely up to individual taste and style and context. So if you have data that require radians, then ggplot2 can change the coordinate system to do that for you. So here, if we sort of apply these last three pieces to our plot. So on the scale, we can see that we have the y-axis is going to be labeled every 10%. And then we've changed the color of the bars. That's also a scale element. We have the axes and plot titles, which are removed because it's fairly obvious what they are. So we don't need to add junk to the plot by labeling them. And the coordinate system is Cartesian. That's automatic. We don't have to do anything there. And then position, we don't need to shift position. So we don't need to do anything there. So now we'll add a few bits of code just so that we have the plot looking nice. So we're changing the scale of the y-axis. We're not naming it anything. We're having the breaks go every 10%. We're using a nice pretty labeler to make it say, 0%, 10%, and so on. We're filling the colors here with the manual values that I've chosen. And then the labs is just going to change the X title. So we're not going to have a title on the X axis. And then we're going to say, let's make a deal is the name of the plot. Okay, so let's see the result. And here is our final result. So you can see that it does not look exactly like what we had when we started. And that's because we're going to talk about some more advanced stuff with using fonts later on. And so, yeah, so you can see that it looks pretty much exactly like what we had in the beginning. So that's great. And now we'll sort of go into more detail. And I know that probably felt kind of fast, but that was sort of the point, was to show you, hey, look what you can do. And so here in this, maybe 8 or 9 lines of code, what we've done is we made this really awesome plot. And what you can see here is that, these first 4 lines or so are really the only thing you need to make the ggplot, and everything else below it is just a style choice. So here's, the full data visualization is contained in these first 4 lines, and then everything else is your style choices. So this bottom part is going to be how you really make the really beautiful data visualizations. Okay, so next we're going to give you more and more detail on the ggplot2 universe, and we'll talk about 1 variable visualization and 2 variable visualization. And then we'll also get into 3 or more. So we'll have colors, sizes, shapes, line types, and so on. And oh, actually that's a typo. I had to take the maps part out to save time, so I apologize about that. So we won't be talking about maps, but there's several links for resources to do maps in the resources folder on the RStudio Cloud. So I'm gonna go ahead and take a couple minutes now for questions. So if there's any questions, please drop them in the chat. And I'll go ahead and see if there's any that I need to check in on with the TAs. So I'm just going to take a couple minutes here. Okay, so one question I see from the TAs is about, so I see a couple questions. So the first one is about the facets, which I'm going to talk about. Let's see, where is the faceting? Oh yeah, so the first one was about using the calls. So this is new syntax to ggplot2 3.3, so the latest version of ggplot2 that just came out. And so the comment is about using the tilde. So the tilde will still work in, I believe, facet wrap, but it does not work anymore, or is being phased out in facet grid. So now, instead of using the old syntax, let me just go over to my RStudio Cloud session so I can sort of show you guys what I'm talking about. So let's see if this plot works. No, okay, I just got to run some code really quickly. Okay, and so what we're talking about here is how we're creating these two columns. And so we've got facet grid calls equals switch. And so the old syntax, we could have done dot tilde switch. And I guess we can see if that works. And it does. But I do know that it's being phased out. So I think the new syntax is to prefer explicitly saying the columns is the switch variable. And this goes along with tidyverse syntax. So if you're familiar with the tidyverse, I'm sure there's a blog post on it. Maybe at the break, I will find a blog post and stick it in the chat for you guys. But yeah, so the tilde thing is the same thing. The other argument we can do is rows, and now it'll be vertically stacked on top of each other instead. Now we have one row for each level. The other question in the chat was, is there an explicit advantage of setting x equals null instead of simply going with x equals empty quotes? Yes, and the advantage of using null over empty quotes is that it removes that element completely. So if you see here, we have our P4 plot, and you can see there's no space, there's hardly any space between the bottom of the plot and then the x-axis. But if I were to make my x equal to empty quotes, now you see that I've created a little bit of space at the bottom here. So sometimes that may be advantageous, sometimes not. But for my purposes, I didn't want there to be any space there, so I just changed it to x equals null. Okay, another question is about how to add or remove background lines in faceting. So when you do faceting, all of the theme elements get applied to the facets. So all theme elements get applied to all of the little small multiples. And so if you want to change the background lines there, you have to change it in the theme function in ggplot, which we'll talk more about later on. Let me just make sure I haven't missed anything else. Okay. Yeah, I think those are the two, or the three questions that they brought to my attention. And so I'll return back to this slide, and I'll go ahead and take a quick peek in the chat. Okay. Let's see. I do see one question that I want to address, which is there a particular way of organizing the code so it is more readable? And so there's, again, this is something that people are very opinionated about. I am not one of those people. I just try to make it more readable for myself. So RStudio does a lot of default things to space code out and doing like indentation and things like that. Which, if you're familiar with Python, you can't do indentation, but in R, space doesn't matter, so you can make it look really nice. So I'm going to put my note to myself to make to put a blog post in the chat later on about that. And I'm also going to put one about the tidyverse syntax for faceting. Okay. Yeah, and I just want to reiterate, guys, Gwen has a good point here. Please do ask your questions in the Q&A and do not put them in the chat. So the Q&A is going to be it's going to be easier for us to moderate and to actually see all of your questions. Okay, let's see. Okay, anonymous attendee number 1 about deciding the variables to use when plotting. I think that's a very broad question, and I will get onto some of that in the next portion. So do pay attention coming up next. And then the second question is, what is the easiest way to remove the space below the bars? ggplot2 makes the bars appear as if they are floating. Yes, that's a good question. It has to do with the scales, which is a more advanced element. And I will also touch on that a bit later on. But I'll also make a note to myself to explicitly talk about removing this space with the bars. It is a bit tricky. There's a good Stack Overflow question out there somewhere. So if one of the TAs maybe wants to find that and drop that in the chat, that would be very helpful. Okay, so I think let's move on to the next portion, because a lot of these questions that are coming up are going to be answered pretty quickly here. So now we're going to talk about one variable visualization. And so these are all of the ways to take one variable and just look at it in ggplot2. I'm a big fan of the comic XKCD, and here is a fun example they have of a one variable visualization, which I like to use to motivate, hey, you actually do see these things in real life, right? And so what we have here is we have the decade of a song when it came out, and then where was the baby boom? And so what we're visualizing is, hey, it looks like these are my parents, right? So every Christmas song is just trying to recreate my parents' childhood. So that's pretty funny. And I'm a millennial, so I sort of get a kick out of that. Okay, so first we're going to talk about histograms. Histogram is your basic visual approximation for a numeric variable. So this is going to show the frequency of values in the range of the data. And what you need is the geom_histogram function. You're going to need the X aesthetic value to map, and you're going to need to specify the width of the bins, or the width of the bars. So what's the range of each bin? How many bins do I want, or how wide do I want the bins to be? And you can also change the appearance of them with all these, and these arguments are all in the documentation for ggplot2 as well, so then you can see all of the possibilities. And so now we have our first your turn here. And so in a sec, I'll give you 2 minutes to do this on your own in your RStudio Cloud, and then we'll go over the solution together. So first, what we have is this weekly NFL attendance data, and you can see the original source on Tidy Tuesday. I think this was from February of this year. So all we have here is a histogram of the weekly attendance of a game. So what we have in this data set is the attendance of all football games played from 2000 to 2019. And we want to make a histogram of the weekly attendance values. So what we're seeing here is the distribution. So what's the most common, what are the extremes, things like that. So go ahead, I'll start the clock and take 2 minutes to recreate this on your own. Okay, so I saw a question about somebody struggling to find the code. So we're going to go through that again, and then we will go ahead and go through the solution for this. So right now I'm going to go over to the RStudio Cloud window that I have open. And let me go ahead and make this full screen. And so I am in the file 03-follow-along.r, and this can be found if you go into the project folder. There's a code folder, and let me make my font just a touch bigger so you can see. So I'm in the code folder, and then I'm in 03 follow along, and you can do the same thing in the slides as well if you want. The slides are in the slides folder. So what I'm going to do is go down to the your turn, which is, so it's line 135. And first I'm going to library the readr package to read in the data. And then I just do read_CSV, and I do the file path. So this you didn't have to do anything for. So now I need to replace these question marks with actual values so that I can make the plot. So the data is going to be attendance, which we just made. So I'm going to type in attendance there. And on the x-axis, we want the weekly attendance. So now if we want to remember that variable name, we can do glimpse of attendance. Glimpse is a dplyr function, I believe. And that is going to give us the variable name. So we can just take this. I'm pretty lazy, so I'm just going to say copy and paste weekly attendance. And we want to make a histogram. So we replace these question marks in geom with histogram. And again, I'm lazy, so I typed hist and I hit tab and it auto-completed for me. So now I can just hit command enter or control enter, and this should run. And now you have the plot. And we can make it a little bit wider so it's a little more pretty. Some other things to do here, we could say these values are in sort of the tens of thousands for weekly attendance at football games. And so we can make the bin width maybe, let's say 2,000. And so that's going to give us a more detailed histogram. We could make it 5,000, and that's going to give us slightly wider bars, or we could go really crazy and not have any detail and make a 10,000, this is not super informative, right? That's not giving us a lot of data. So let's maybe go back to 1,000, and that's going to be really, really detailed. So that might be too skinny. So let's maybe go back to 2,000. So various things you can iterate for yourself, for your purposes. But that's the first your turn example. Okay, I'm going to pop into the Q&A really quick, see if there's anything. Okay, so there's one question about each week being repeated multiple times in the data frame, and that's true, and that's because it's each week is repeated for each team. So you have all teams in the NFL are in this data set, and then you have all games that all teams have played, and that's for 20 years of data. And so what we're seeing here is this is every single game that was played in an NFL stadium. What was the attendance in every NFL game for all of the games from 2000 into 2019? So I hope that answers that question. Okay, so let's go back because I have another your turn, ready and loaded here for you guys. So we'll just go to the next one. We have the next one, variable visualization, is going to be a bar chart. And so this is the discrete version of the histogram, or the discrete or categorical. Those are equivalent. And so you use the geom bar function for that. And this is going to require the X aesthetic inside of AES again. And again, you can change the appearance with color fill, alpha, and so on. And so what you are going to do now is you're going to take a couple minutes and do total NFL attendance. And so I've given you a lot of code here because this is kind of a tricky one, but this weight variable, what it's going to do is it's going to add up the weight for all attendance for all teams in the NFL for all 20 years. And that's why we're getting these numbers here, 1.5 times 10 to the 7, right? Those are pretty big. And that's because it's all NFL attendance for that team for 20 years. So let me go ahead and start the 2 minutes. Okay, I'm seeing some questions about the removing values. And so what's going on there is the weeks during the playoffs in the NFL. So not every team is going to be in the playoffs. And so those values that are dropped off, there was no game played for those teams. And so that's why they're missing. So don't worry about the warning. I know it's scary because it's in red. They should really change that. Okay, so we have 2 minutes is up. And so I'm going to pop over again to the RStudio Cloud. And so if you go to your RStudio Cloud window and you go to follow along, this is going to be on line 152. So let's go ahead and make this code visible for everyone. And we're making a bar chart here. So we're using the same data as before. So we want to say data equals attendance. And we need the AES mappings. So we want X to be equal to we want X to be equal to, what was it? Complete the code below to display a bar chart of total NFL attendance by team. So that we want to be the team. And let me just check up here where I looked at the data. That's going to be team underscore name. And the reason we're going to use team underscore name as opposed to team is because the team is going to correspond to the location. So like Arizona, Chicago, New York, and there are 2 New York teams. So we don't want to use team, we want to use team underscore name. And then we use geom_bar, and then I'm using a trick here, chord flip. And what that's going to do is make it so that we can easily read all of the team names on this side here. If I don't do that, then I end up with these bars and all the team names get crunched. So it's just to make it easier to read. So let's make this a little bit bigger. And so we see here that it looks like this team, it's pretty close between this bar and this bar, but I think it's this team with the largest attendance overall 20 years, and that's the Cowboys, which are the Dallas Cowboys. And my mom is from Texas, and I know that football there is a very big deal, so that makes sense. Okay, just gonna pop into the Q&A really quickly to see if there's any questions about this. So the weight argument inside of the AES, that was used to weigh the bars. And so what that is doing is, instead of, if we take out the weight argument, let me show you what happens here. So if we take that out, we just have counts of, this is the number of observations in the data set. So you can see there's 300, I think it's 340 games. So this is now just showing you how many games that are in the data set. And I think I guess the Texans are a little bit of a newer team, and so they don't have quite as many games. And so the reason we have the weight is because we wanted to show the total weekly attendance. So now instead of just counting the rows in the data set, which is the default behavior of GeoMBar, it's going to be weighted according to weekly attendance. And so behind the scenes, it's computing the sum of all of the weekly attendance for all 20 years within each team. And now it's showing us overall. So that was a great question. Thank you very much for that. Let's see. So any questions about code? That you should be able to see that in your own instance of RStudio. So keep that in mind. Let's see. Oh, and there's a couple of questions about weekly attendance and sorting from biggest to largest bars, which is great. That's super common. That's what we'd want to do. So I'm going to see if there's a way to do that the quick way, and then I'll do the longer way. So we are going to do around the x equals team name. So we're going to put parentheses around team name, and we're going to say reorder the variable team name according to weekly attendance. And let's see if that works. And it didn't do anything. Okay, let's try a new trick in ggplot, which is after stat. Let's try that. And that gives me nothing. Okay, so the question is, so for the quick way to do it, I do not know how to do it, but what you're going to want to do is do some data manipulation for that. So then what you want to do, oh gosh, this is kind of advanced. So how about I'll just do it and I can drop the code in the chat. So this is dplyr code. And so now what we're going to do is we're going to sum all of the weekly attendance for each team. So I'm going to make a total attendance, and that's going to be sum of weekly attendance. And so what we can see here, oh, and I forgot to remove my NAs. NA.rm equals true. So now we have the total attendance, and now we can pipe that into a ggplot, and now we can do the reorder thing that I wanted to do. X or team name total attendance. Oh, I forgot a geom. And I'm going to do chord flip as well. Oh, I need geom call. Okay, so what's happening here? Okay, so I tried to use GeoMBar, but I couldn't do that because it's not counting up anything. I want to give it explicit values. So now I'm trying to use geom call, and it's making sad face at me because I did not give it a Y argument, which geom call requires. So now I'm going to use as my Y variable total attendance. There we go. Okay. So now what I've done is first, I used a little bit of dplyr code to create a variable called total attendance, which is going to give me a data frame of the team name and the total attendance, and where the total attendance is the sum over all 20 years of attendance for each team. And then what I did was on the x-axis, I put the team name, and then I reordered it according to that total attendance variable. So now you can see the team with the most attendance is at the top, and the team with the least attendance is on the bottom. And there's also a new way to do this in ggplot2, which is you can make the Y variable the team name, and then you don't need to coord flip it. So we're gonna, then you can see that that gives the same exact output. So either this is the solution or the previous, let's see, so that's the solution, or it is like this. So I think because people are asking for charts like this so frequently, they just made it so that you can make the y-axis the variable that would normally be on the x-axis. Okay, so hopefully that answers that question. Let me just peek in the Q&A one more time. The question, does it randomly pick a value to weigh if you don't include the weight equals weekly attendance? So the default weighing is the number of rows. So before, if you don't give it the weight variable, it's just going to count up how many instances are in your data set. And geom_call worked because geom_call takes an x and a y value. And so geom_bar only takes an x value. And so we could also probably use geom_bar. So with ggplot, there's always at least 2 ways to do everything. And so what I might try here now is to use geom_bar. And so now I'm going to use, let's see, let's use x equals the team name and weight equals total attendance. So now I'm going to use geom_bar and coordinate flip. And there you have the same thing. And so now I didn't reorder it. So let me just copy pasta. Like that. So you can use geom_bar. It just depends on how, yeah. ggplot2, there's a million different ways to do everything. So for sake of time, I'm gonna step out of here and I'm gonna go back to the slides. So finally, the last one variable visualization we have here is the density plot. A density estimate is just a smooth version of the histogram. And again, one variable, we only need the x-aesthetic. There's various other things you can use to adjust it. And here I just have the same exact thing as before with the histogram, but I just have geom density instead of histogram. And so now you can see instead of bars, we get a smooth curve. And you can adjust how smooth the curve is with various parameters, you know, with the adjust parameter, or you can change the way the smooth line is drawn. That's sort of a more advanced stats concept if you're into that. And for now, okay, oh, I forgot. Yes, there's other one variable visualization tools that you can use. Frequency polygon or geom_freq poly is just the same as a histogram, but instead you just draw a point at the top of each bar for the histogram and then connect the lines. geom_rug is down here at the bottom. It's just drawing a small skinny line at every instance. So this would be good if you had maybe a scatter plot and you wanted to show the distribution of the y variable and the x variable independently. If you wanted to show those marginal distributions. And then geom.plot is kind of a weird one. I don't really ever use it in practice, but it's there and it just draws. So these are not bars, they're little points stacked on top of each other, one for each observation in that width. And all the code for these is in the slides. I just didn't, or is in the slides.rmd file. I just didn't present it on the slide because it's not as important. So now I'm going to take, I think we should take about a 5-minute break just so we can sort of cool our jets a little bit. I'll turn Fleetwood Mac back on and then we'll be good to go. So I'm going to turn off my mic and my video and I'm going to turn my computer sound back on for about 5 minutes. And so we'll meet back here. My clock says it's 3:03 right now, so we'll meet back at 3:08. Okay, thanks so much. had a nice break. I put in those 3 questions that I meant to answer in the chat. So you should all be seeing those now in the chat. Okay, so let's continue on with 2-variable visualization. Again, here I have a fun little real world example of a 2-variable visualization. And I guess really, if you want to be pedantic, it's a 3-variable visualization, because the 3 variables are how easy it is or how difficult it is, you know, the difficulty level of eating the fruit versus how tasty the fruit is. So you can see here, seedless grapes, pretty tasty, very easy to eat, whereas pineapples are very tasty and pretty difficult to eat. So this is just a fun little scatter plot. And so another thing I like to do, this will answer some of the questions we had earlier on about, you know, which data am I plotting here, which data am I visualizing? And so you have there's 2 different basic types of data, right? You have numerical data and you have categorical data. So if this is a little matrix for you, so say you want to make a 2-variable visualization, you want to make a scatter plot or something like that. So now you know that you need 2 numerical variables to do that, because you have one numerical, you can make a scatter plot. If you have a numerical and a categorical variable, you could make a box plot. And if you have 2 categorical variables, you can do a mosaic plot. And I've added some information about a package there that you can check out. You can do counts or something like that. So we'll see examples of all of these, but this is just for your reference of all of the things that ggplot2 can do. And so I went ahead and I put the geomes, so geome underscore blank. So I put those here for all of the different possibilities for your 2-variable visualizations. Okay, so let's start with 2 numeric variables. Let's start with time and weekly attendance. So the time variable in the football attendance data is just a variable that I created so that I could look at all of the games at once, sort of side by side, right? Because, you know, there's a whole year in between football seasons. So I didn't want to use dates because there would be a lot of big gaps. So it's just a time variable that I manually created to make it easy for us to look at attendance over time. And so now I have weekly attendance as my other variable. And I'm going to use data only from the DC team. And one thing here that I'm not a fan of is the way this code font has rendered. This is a double equal sign. So this is equals equals. It's not a single one, it's 2 of them. And that's going to be important. So now what I'm doing is I'm just using a little bit of dplyr code to create a data set called DC, which is only data from the DC team as opposed to all of the teams in the NFL. And so this is going to now, we have 2 variables, so now we need 2 aesthetics. And then again, as before, we can change, you know, color, line type, etc. We'll talk about that in a little bit. And we'll talk about grouping later as well. So now again, it's your turn. So go ahead and take a couple of minutes to complete the code and make this time series chart. So I have the time variable on the x-axis and then weekly attendance on the y-axis. So 2 minutes starting now. Okie dokie. So that was 2 minutes, and we will go ahead and look at this code in the RStudio Cloud. Okay, so if I'm going over to the code, so this section, let's see, to read the data, you're on line 205. So I'm reading in my, or I'm not, you're not reading in the data, you're creating a new data set with filtering, technically. Okay, so the code we're gonna complete is on line 217. And so we need to complete the code to make the time series chart of weekly attendance from 2000 to 2019. And so again, I've sort of left you some blanks here. So we're gonna use ggplot, data is DC, which we just created. I told you that X is going to be time, and Y is going to be the weekly attendance. And now I'm going to use geom line. And let's see what we get. Here we go. Okay, so you can see here, time, there's over 340 games, and then you can see some gaps. So there's gap weeks in the NFL season as well. So every team takes off 1 week in the season. And so you can see the gaps for each year are also visible in this data set. Okay, I'm gonna, no, it doesn't look like there's any questions about that. Okay. Great, so we'll move on to the next one. So now we're going to do one numeric variable and one categorical variable. And so again, we're going to use the team variable. And then, whoops, I think I zipped forward there. Okay, this is a typo. So this should not be weekly attendance. It should be team name. So ignore this. This should be team name, not weekly attendance. So that's a typo on my bad. So then we're going to use geom box plot. So again, X and Y. And so what it's going to do is it's going to draw a box for each team. And so that's what we've got here. So using geom box plot, modify the code below. And then I've given you the coordinate flip trick again. And so now it's drawing a box plot for each weekly attendance instead of the total sum. And so I'll start the clock for that now. Okay, so our 2 minutes are up, and we'll go ahead and create this box plot in our Studio Cloud. And let me make the code a little bit bigger. So again, this was supposed to say team name, so my apologies about that. So here's the code we need to modify. And we're going to use the full attendance data set. So data equals attendance. And on the x-axis, we want to have the team name. And on the y-axis, we want to have weekly attendance. And so the geom we're going to be using is box plot. So let's see what that gets us if we run this code. And again, you can see we're getting that warning message where there's no games in that week for a given team, which is fine. We can ignore that for our purposes here. And so again, what we have here is a box plot of the weekly attendance values for each team. And so this is kind of interesting because we can see that some have really wide variation. So the Cowboys, you have, on any given day, you can have as little as, 40,000 to as much as, over 100,000. So that's very interesting. And you see that, there's not a lot of outliers there. They're all pretty widespread. But then you have some that are more consistent. So here, let's see, look, this one in the middle here is for the Eagles. So you can see that the middle 50% is very, very skinny. So it's mostly between, maybe what is that, like 71 and 72,000 people attending most weeks. And then you have some lower outliers and some higher outliers. And again, we're seeing here that the highest attendance is garnered by like the Cowboys. Is that the Giants? Yeah, New York Giants is another big one. Yeah, okay, so let's pop in the chat really quick, see if there's any questions. Oh, good question. How to update the number format on the axis? Good question. So that's in the scales portion. Let me just see if I can do it on the fly real quick here. So scale, now that's going to be X continuous. And if I want the labels, I'm going to change the labels. And there's a function, there's a package called scales, which has a bunch of functions inside of it. And that should be, let's see, pretty, it's just like pretty function or breaks pretty or something like that. Pretty, gosh, I really don't know the name off the top of my head. But what we can do is we can say as dot character, let's see, what is that? That's 2 to the 1, 2, 3, 4. We can make a sequence. Oh, geez, this is really convoluted. A sequence from 20,000 to, let's say, 100,000. And let's update it every 20,000. And that's going to be our labels now. Let's see if that works. Did not like that. So now we need to make the breaks the same thing. So now breaks equals that, and that should work. Nope, it did not like that. Let's try scale Y continuous. There we go. Okay. And so now you can see here, oh, let me make this full screen again. Apologies about that. So what I did was I have Y here. And so I got tripped up because it looks like it's the x-axis, but because I use coordinate flip, it's actually the y-axis. So that's why we need scale Y continuous. And we use scale Y continuous because it's a continuous variable, continuous numeric variable. And the labels, what we're doing here, first, it's better to talk about the breaks. So first we break it up. We want it to go every 20,000. So I had it go from 20,000 to 100,000 by 20,000. And then what it's doing is I'm saying, okay, as.character, do this sequence. And so now it's just taking the raw numbers. And the reason the last one is like that is because if you you type in 100,000 into the R console, it automatically creates 1 e to the 5. So now it's just going to make that a character instead. So we got almost all of the way there. If you do some Googling, I'm sure one of the TAs can find a Stack Overflow question that can answer that in some more detail. Pretty prints, you can do commas and things like that. So again, sorry I didn't have that off the top of my head, but that was a good question. I pop in here. So somebody says labels equals scales labeled number. So that, let's try that. So I'm going to comment this out. And we'll say scale y continuous labels equals scales labeled number. Let's try that. Oh, there we go. Nice. And so I'm sure there's an argument in here, depending on your country. In the US, we use commas for that. I know in some European countries, they use points for that. So yeah, in some other countries, they use space. So yeah, great. Thank you so much for that. Let's return now to the slides. Okay, and so the last one for 2 different variables that we're going to talk about is categorical variables. And here I kind of cheated because year is technically a numeric, and so is week. But for this for our purposes, years are more like seasons of the football team, and so those are really maybe they're a little more categorical than that. But just for purposes of demonstration, we have the year on the x-axis, the week on the y-axis, and then we're coloring those bins according to the weekly attendance for just the DC team. And so now we can see that the darkest green color is the highest weekly attendance. So something like this is game 13 in 2017. And the lower attendance is on the white scale of things. So then we have this really, really low attendance one, game 14 in 2017. There's probably a blizzard or something in DC that year, and that's why that happened. So again, you have this here. For the sake of getting to the really fun part at the end, I'm going to sort of speed up my pace here. And again, you do have all of this information in the RStudio link. You can compile these slides, look through them yourselves. Yeah, so again, I'm going to speed up for the sake of getting to the fun stuff. So now we'll talk about 3 or more variable visualization, which just, to be clear, you cannot do 3D things in ggplot2. There are ways. Go on Twitter, find them. People do it. I'm not going to teach you how to do it though. And then the other thing about ggplot2 is that it's static. It's not interactive. And so if you really want to get into interactive graphics with ggplot2, a great place to start is the Plotly package and the ggplotly function. So that's a link, again, that's available to you in the slides. But there are plenty of other ways to make informative static graphics with ggplot2, and that's what we're going to get into. So again, we can talk about adding color, we can talk about adding size, shape, we can do contour lines, we can do different binning things, we can make tiles or hexagons or whatever. So there's lots of different things that we can do. And here's another chart that I stole from somebody else's tutorial because the art community is so wonderful and loving that they just put all their material out there. And I really loved this chart from Garrett Gralmund. And you can see here, if you have a discrete variable versus a continuous variable, and then the different aesthetics you can apply to that variable and how they're going to look by default in ggplot2. And so you can sort of compare and contrast here. And note that for continuous, you cannot do shape because there's not really a meaningful way to map a continuous variable to different shapes, right? That doesn't really make a whole lot of sense. Okay, so first what we're going to do is add a discrete / categorical, discrete AKA categorical variable. And before, like I mentioned, New York has 2 teams, which are the Giants and the Jets. And so again, I'm just creating a data set called NY, and that's going to have just the teams from New York in it. And so now I can make the same time series that I made with the DC team, and I can now make those with the Giants and the Jets. And so I just plot here, I say my data is the New York data set, time, weekly attendance, same as before, and now I'm going to color the lines according to the team name. And now you can see that the red line is the Giants and the blue line is the Jets. And I'm using a little trick here inside of geom line, which is alpha equals 0.7. And so what that is doing is that's telling ggplot, hey, I know that I'm going to have a lot of overlap in my data, and I want you to make them a little more transparent so I can see, you know, one is going to get plotted first and the other one will get plotted on top of it. So I want to see them both, and I want you to make the one that's on top a little more transparent, and they'll actually both end up being a little bit transparent. So this value goes from 0 to 1. So I made it 0.7. So they're mostly opaque, but a little bit transparent. The next thing I can do is I can use line type to indicate team. And so here you can see that I have I've added a line type equals team name argument instead of color equals team name that I had before. And you can see here now the team name, the solid line is the Giants and the dotted line is the Jets. And again, I've done the little alpha trick. Now I'm going to use size to indicate the team. And you can see here that there's a really fat line for the Jets and a really skinny line for the Giants, or maybe a not so skinny line, but it's definitely skinnier than this one. And so I just wanted to note that though this is possible, I do not recommend this. And if you can maybe drop in the Q&A why I don't recommend this, just drop what you think. And I'm sure somebody will have the right answer. Okay, so the answer is that the size, because of the inherent number that's there, right? Something is bigger than something else. We don't really want to use that for a categorical variable, right? Because we're just talking about two different categories, right? It's difficult to interpret, so thank you for that. Yeah, so because the Jets aren't necessarily bigger than the Giants in any way, we're just showing the two different groups. So we don't want to do that when we have categories. We just want to do that when we have numerical variables. Excellent. So speaking of numeric variables, now we want to look at adding another variable to the plot. So now we're going to be doing 3 different numeric variables, and for this we had to get a new data set. So again, if you're following along in the O3 follow along.r file, this code, you can just run this right in there, and it's going to be available to you. So what we're going to do is we are going to look at the yards gained for the losing team. And you know, I grew up with my dad watching football, and I don't understand it a whole lot still, but you know, yards is how far you're running up and down the field. And so presumably if you have more yards, that's good because you have to run to score the points. Okay, I'm not baseball is my sport. Okay, and so on the x-axis we have the number of yards for the losing team. On the y-axis we have the number of yards for the winning team. And again, I should probably note, apologies to my international audience, where football is what we call in the United States soccer. So this is American football. Hopefully that was clear from the outset. So again, apologies in advance to my international audience. So yeah, so what we're doing here is we're looking at this new games data that we read in, and we're using 2 variables to make a scatter plot. So we want to see, so is there a relationship between, you know, how many yards the losing team gets versus how many yards the winning team gets? So we might think in our heads, you know, oh, maybe there's a relationship, but we can see here from this giant cloud of points that there doesn't really seem to be a relationship, that probably, you know, football, you know, professional sports are pretty competitive, and, you know, most teams are about, you know, relatively equal, give or take a few things, you know, so there's not really a relationship. So if your opponent is scoring a lot and running a lot of yards, then you're also probably going to be doing that. And so I've colored this, or excuse me, I've made this size here according to the point spread. So this is the number of points that the winning team won by over the losing team. So you could have, you know, the winning team scored 30 points and the losing team scored 20 points. So the point spread would be 10 points. So you can see here that there's some bigger points here where the losing team has significantly less yardage than the winning team. So that's just something we can look at there. We can also color the points. So these light blue points now are the really, really high point spreads, and the dark blue ones are the low points. So those are the really close games. So you can see kind of in the middle over here, there's a lot of really, really close games. And then over here, we have more of like the blowout games where one team is winning a lot more and running a lot more yards. Okay, switching gears now, we're going to hop over back to different aesthetics that we can use. So we're going to use the group aesthetic, and we're going to go back to the New York data set where we had those two different teams. And so what I'm doing now is I got tired of looking at those huge squiggly lines. So I'm just filtering it down to only 1 year, 2019. And again, this is a double equal sign. And so what I've done on the left here is this first line of code where I just say, okay, X is time, Y is weekly attendance, and draw a line. And you can see that it looks kind of funky, and it's getting confused because there's 2 data points in each time point. So this one here, it's drawing 1 point for the Giants and 1 point for the Jets. And that's why it's sort of looking a little bit confused. And you can see here in the second line of code, which is representative of the graph on the right, we're using group equals team name. And so now we can see that there's clearly 2 distinct lines for each team. And now because it's grouped and we haven't given it something like color or line type or something like that, they're not labeled. So we don't know which team is which in this graph, but now we can clearly see that there's 2 separate lines. So this might be good if you're running a bunch of different simulations or something like that, and you just want to look at all, 100 simulations at once. You can use the grouping variable. Here's many, many groups. And so I did the same thing with the full attendance data set for the full time period. And the group is now the team name. So I did the same exact code before, just with the full data set. And you can see it kind of looks like gobbledygook, right? You have this big thick band in the middle where weekly attendance tends to go from, 65,000 to about, 78,000 typically in a game for the NFL over time. And then you have some clear outliers. You have some ones that are much higher and some ones that are much lower. And so now what we can do is we can add a little bit more information. So in that data set, there's a division. And so the NFL is split into 2 different conferences, and within each conference, there's 4 divisions. So you have conference AFC versus conference AFC, and division are parts of the country. So the East, the North, the South, and the West. And so now each color represents a division. And you can see here, there's a little bit kind of a trend of the red line being a little bit higher. So that's the East. So it looks like maybe the East divisions tend to be more well attended than the purple line, which is going to be the West division. So those are going to be a little bit less well attended than in the East. So that's one way to look at it. But again, this is kind of messy, so we might want to split it out. And so for that, we're going to use facets. And we've already talked a good deal about facets, and I've dropped you that link in the chat for that as well. So I'm going to go through this kind of more quickly than I had planned on. So what you want to do is you just want to either use facet grid to stack them side by side, or you can use facet wrap, and then facet wrap has all these other arguments, nrow and things like that. Okay. So now we're going to get into more of the advanced customization stuff. This is how you make graphs really cool and beautiful and do really fun things. And this is a piece of artwork by an artist and professor named Danielle Navarro. And she has written several art packages to make this really cool generative art. And these are all ggplots that she's made. So I think that's really excellent. I wanted to highlight that. The first thing we can do to do advanced customization is combine layers. So ggplot, the grammar of graphics, is all about stacking layers on top of each other. And so what we've done here is, this was that same scatter plot before where we thought maybe there's a relationship between these two variables. And so what we're doing is we're adding the geom_smooth, and we are using a linear model. So we're just fitting a line through it, and we can see that it's pretty flat. Maybe there's a little bit of a relationship, but not so much. So it doesn't look like there's any correlation between these two variables, and that we did by just using the same data. So that now what this is doing is it's taking all of these AES values, and it's basically copy pasting them internally into this geom_smooth function, and now it's drawing a line through the data. So that's that. And I'm going to go ahead and skip this your turn. I'm just going to go through the code for it. So then if I go in the follow along, what I'm going to do is go down to, gosh, where is this? Here we go. Yes. So we need to recreate the visualization, and I'm going to, so this is the same one from the many groups. So if I'm being really fast and efficient here, I'm going to go to many groups, slide, and I'm going to copy and paste this code. So I take this same code that's from line 336, and I'm going to go ahead and paste it. And now you can see that I've made this crazy, horrible looking chart with many, many lines. And now what I'm going to do is I'm going to add a smooth. So geom_smooth. And if we look back at the chart, I need one line for each division. So that's telling me that inside of smooth, what I need to do is I need to make sure I'm coloring according to division. So I go over to smooth, and I know I need to color according to division. So I have my AES function, and then color equals division, and I hit enter, and let's see what happens. And so now you can see I have all these lines sort of overlapping. Let's see, what do I want to do? So there's a couple things going on that are making this not look exactly like the one that's on the slide. So first of all, I have one line for each group, which is going to be the team name. So I'm going to want to get rid of that because I just want it to average over all of the teams in the division. And so I'm going to add that back in here. And so let's get rid of that. And then I'm also going to get rid of the standard error around, so those little gray bars around the lines. So there, that's what I ended up with. Let's make it a little bit bigger. Whoops. And so now you can see it looks like the slide. So we can see now that clearly the East over time has greater attendance on average, and then maybe the West and the South kind of alternate. But that just could be because, you know, the eastern part of the United States is more densely populated or whatever. Okay. So sorry for speeding through that, but again, I want to get on to some more of the fun stuff. Here's another one where I'm using a different data set. So in this set, what I've done is I've drawn all of the attendance. So I did that same plot that I just had before. And then I've added on top of it a line to emphasize the DC team. So I live in DC. Maybe I would be interested in going to a football game in DC. I'm not, but if I am, I could go ahead and peek at the attendance of just the DC team on top. And I've made it blue so that it's clearly emphasized, and we can sort of compare it in the background to all of the other teams. So actually this DC team is one of the better attended in the US. Okay, graph appearance, this, I think I'm gonna skip a significant portion of this just for the sake of time. I want to be respectful of the time slot. We said 2 to 4, and it's about 15 minutes until the end of that time slot. So here's a funny graph that Will Chase made. Here's a link to his Twitter account if you want to follow him. Pretty funny. This is just more details on scales. A lot of like making ggplots really nice involves just doing all these little tricky things with scales and themes and stuff like that. And so here I'm just using different scales to change the appearance of the graph. So here before I had, the default ggplot colors, and now instead I'm making the lines match sort of the team color. So the Giants have this like navy blue color and the Jets have this green color. And so that's what I've done here. Again, I really apologize for just like flying through this. Again, labels, as always in ggplot, there's more than one way to do everything. So you can make a title with ggtitle, or you can make it inside of the lab function. You can use the xlab to name your axis titles, or you can do it within the scale function, or you can use the lab function and say, x equals y equals yada, yada, yada. There's lots of different ways to do everything. The one thing I do want to emphasize is the coordinates. This is a really tricky point that not a lot of people get, and that I really want to emphasize for you guys. So the three visualizations that I have here all begin with the same plot code. So they're just the DC team weekly attendance over time, right? We've seen this plot all the way on the left several times before. And now what I've done is I've just decided to make breaks manually every 17 lines, because I know that in the data there's 17 games in every season, and I just go through 1 through 17, and the first one is always the start of the year, so 2000, 2001, and so on. And sorry if that's super tiny. But now what we want to do, let's say we want to zoom in, right? So this graph here is kind of hard to see what's going on because it's 20 years of data. So what if we just want to zoom into, let's say, the last 2 years of data? We want to look at 2018 and 2019. And so now what we've done is I've used this limits argument inside of the scalex continuous function. And now what that's doing is that's saying, okay, cut off my data. I only want to look at, on the x-axis, the values from 324 to 340. So get rid of everything else outside of that interval. That's what that's doing. And then on the right, what I'm doing is really what you want to do when you want to zoom into a graph. So instead of doing that to scale x continuous, because that's going to tell ggplot to discard some of your data, instead what you want to do is you want to use the coord_Cartesian function, and now you want to tell it the x limits. So you say, okay, I'm only interested in the values from 324 to 340, right? And so, or 30, I think this over here should be 307 to 340. So that's the last 2 years in the data. And so now you can see the key difference here is right here. You can see that it's now not discarded the data and the time point before we're interested in. It's just sort of zoomed in to focus in on the time point that we're interested. So this data is still here, whereas over here on in the middle graph, it's not there. So that's a really kind of a neat trick that's good to know. Okay, so themes, again, I'm going to skip over some of the themes. There was a good question earlier on that I got texted about, which was, how do you change the color of the strip of the background of a facet? And that's part of the theme element, so you'll want to use that. Something to note here is that within the theme function, so within this theme function, two things. One, if you want to change an element that shows data, you're going to use AES or scales. Otherwise, you want to use themes. So that's anything to do with the grid lines, the background, where the legend is, all of that stuff is theme, because those are not directly tied to the data. And so there's different theme elements you can use to modify. The ggplot2 documentation is really excellent. Please read over that if you want to look at themes. And do note that there are 92 possible arguments inside of the ggplot theme. What I do is I stick to one base theme and then I modify from there. So I will say, theme underscore BW plus theme, and then I alter my elements from there. So that's what you guys should do too, just to save yourself some typing. Here's a really ugly theme I made just to show you can do like all sorts of insane things. I would never, ever recommend making this. Okay, I really want to get to the last, for the last 10 minutes, I want to do animation. So again, apologies, and I do want to respect your time, but I showed you the animation at the beginning, and so I want to deliver those results. So the extension of ggplot2 that we're going to talk about is ggAnimate. And again, I have a really cute illustration here from Allison Horst for ggAnimate. And there's tons and tons of ggplot2 extensions. there's a website linked here. You can visit them. But the first one is ggAnimate. I think that's the most popular one. And so ggAnimate is a grammar of animated graphics, and there's lots of different function families, and I highly recommend reading over all of the documentation and watching Thomas Peterson's talks about them. He's the author of ggAnimate. He completely rewrote it a couple of years ago. I was using it back in like 2015 when it was something completely different. Maybe it was 2016. Gosh, time flies. And so it was totally different before, and now he's got this whole new setup, and it's really, really cool how it operates. So there's these key functions that you want to know, and I think I stole this directly from the documentation. But basically you can transition. So this is going to tell you how to go from one static image of your animation to the next. And view is talking about your scales. So that's things like zooming in and zooming out, and following along as time goes on, things like that. Shadow is what that's gonna do is it's going to create, say you have some data coming in and you want it to go out. How do you want it to go out? Do you want it to stay? Do you want it to leave completely? Do you want it to sort of be faded out? That's what shadow is gonna do. Enter and exit, that's the same thing. So, do you want it to fly in from the top right corner? Do you want it to bounce in like a bouncing ball? Things like that. That's how you're going to do that. And then how all of these things are transitioned. And then these are just some basic functions that you can use to transition all of those things. And again, I have a little note here. So for optimum performance, you're going to want to use the animate function to create your animation. You don't just want to rely on what it's doing in the console because it's skipping some steps to be faster. And then you want to use the anim_save function to actually write the GIF to your computer. Okay, so now let's get into the example data. So the example that we have here, this is the raw data from the simulations that I ran of the Monty Hall problem from the very beginning. So you can see that, we have each sim is, 1, 2, 3, 4, yada, yada, yada. And then we have whether they switched or not and whether or not they won. So these first two are really fun because on the first simulation they switched and they won, and on the second one they didn't switch and they lost, right? So that's pretty funny to look at. Okay, so now here's some code, and this is directly available to you. All you have to do is just run all the code above it in your file, and you should be able to easily access and create the animation. So I'm going to do that right now. And the highlighted lines are the ones that are directly containing elements you need for the animation. So you need this sequence along sim variable in order to create one frame for each simulation. And then right here, what you're doing is it's going to label according to each frame. So that will label, 1 through 100 for each simulation. And then we're going to use this reveal transition. And again, we need one image per simulation. So let's go back over to the cloud. Okay, so I read in my data, and now I do ggAnimate. So you can see this is taking it's taking the time to actually render the graph. And now it's going to take a little bit more time to actually stack all of the images together. And so by default, it just makes 100 frames. And so now we can see that each of the, we can see each simulation. So this is a new simulation counter, and then the results get sort of stacked on top of each other. Okay, and so now let's take a few minutes to sort of go through if you want to take a couple minutes on your own to do this, here is your turn. I'm not going to do 6 minutes, just there's a few question marks in here. So actually, you know what? No, I'm not going to do that. I'm just going to go through it with you because it's pretty tricky. So just a reminder of what the GIF looked like at the beginning. So something interesting here is that now we're emphasizing each one with a gray outline. And so what that's going to do is that's going to tell us, basically I wanted to do that because I wanted to emphasize each simulation stacking up on top of each other. And so what I'm going to do is I'm going to go back and I skipped talking about the fonts, but there's some font action you have to sort of deal with in here to get that cute little font to run. But if I go, let's see. I'm just going to go through the solutions. So if you haven't figured it out already, the solutions to all the your turns are in this file over here. And so here is the full code to make the animation from the very beginning. So that's this code right here. And so first what I did was I used geomrect, and I'll sort of show you the result from that. So now you can see that each rectangle, and I had to do a little bit of pre-calculation. So let's go ahead and show the next line as well. Whoops, it's not rendering. There we go. So now we have one little bar for each instance of the simulation. And I calculated a couple variables like perk and perk2. That's sort of like cheating, so that I could make this cute little animation. If I do a couple of other things, I'm changing the breaks. And something to note here is that I'm using geomrect instead of geomcall or geombar. And that's because I really wanted to emphasize, you know, I really wanted to focus on stacking them up one by one by one and really, really showing that to the viewer. For some reason, it is not letting me run it. Okay, that's really annoying. What the heck? Okay, well, my RStudio Cloud just decided to stop working, which is super fun and cool. Okay, so now what I'm going to do is I'm just going to make the animation. But again, all this code is available to you. And apologies for the time frame. This was originally a 4-hour, 2-day tutorial that I gave at work a couple of months ago. And it turns out that I needed, I didn't cut out quite enough, which, you know, I wanted to give you guys as much material as I could. So again, I apologize for the rushed nature of this back half, but I think that you guys asked a lot of really great questions in the beginning, and I think that that was really helpful for me to go in and sort of answer those one by one and sort of go through the code with you to show you just how cool and how many different ways there are to do things in ggplot. And so here's a fun little animation for you. And let me just go back to the slides real quick and I'll wrap up. Yeah. And so that's it. And again, I just want to thank you all so much for your time and for coming to this. This was really exciting for me. I was really excited to be a part of useR. This is my first time being a part of useR, so I'm really excited. I was so disappointed when in-person event was canceled, but obviously it's for the best, you know, given our current global situation. And I just want to again thank everybody at useR and thank you all for your time. Here are some additional resources for you to learn more. The ggplot2 book is excellent. It's all online. The Plotly book is good for interactivity, and that's all online. R for Data Science is good if you want to learn more about some of the dplyr stuff that I was doing. Tidy Tuesday is great. People always are posting their results. So Tidy Tuesday, they're not the results, but every week they issue sort of a new data set, and it's sort of practicing your tidyverse skills. So flexing your data manipulation, data visualization skills. You know, people like to post screencasts, or they will put their plots on Twitter, things like that. So that's really fun. I wrote a blog post about how to get help in R, so I definitely recommend checking that out, just because a lot of questions that you have already been answered. And so how do you find those answers to your questions? It's a really good post for that, if I do say so myself. Another one to check out is Thomas Peterson. So he's the ggAnimate developer. He's made a bunch of other packages related to ggplot. and he's also part of maintaining ggplot2 now, I believe. And so he has, I mean, 5 hours of material. Talk about, I'm like scrambling to get through 2 hours of material. So he has, you know, if you want it more, he has it. There's almost 6 hours of material there, I believe. RStudio cheat sheets are good for like quick reference. Back when I was in my office, I had them easy access for me at all times, just so I can sort of, if I have a quick question, just peek on the RStudio cheat sheet. There's a good design talk, so that's more about styling, so good visual design principles, if you want to learn more about those. I've also linked here the RStudio Cloud project, so the same thing, but for the 4-hour version of this workshop, and that one is I did for work, so that's very focused on the United States Bureau of Labor Statistics data. So if you're interested in like the economy or anything like that, you might be interested in that. And then the resources folder within the RStudio Cloud project. And so now you guys have all of this material, and I really hope that you can just run with it and just make really beautiful visualizations. So again, thank you so much. And that's it for me. Thanks. I see one question. My apologies. I'll go through. Sorry, I got so flustered. If you guys have a few minutes, stick around. I can definitely answer some more questions. I did see one texted to me by the TAs. So if there are multiple AES statements within a ggplot call, which takes precedence? So that's a great question. The aesthetic. Let's go back. Actually, I'm going to go back to the RStudio Cloud because I used this example. Okay, sorry, bye-bye animation. You're so cute. I used something like this earlier when I was doing the grouping. If I can just find it. Okay, here's a good example. If you want to stop, somebody just texted me, if you want to stop a ggAnimate simulation, there should be a little stop button, or you can just X out here like that. Okay, so for whatever reason, my plot window is not working anymore, which I'm really upset by. Maybe if I go, okay, there it goes. So, so here's an example of different AES function calls. So when you put an AES function call inside of a ggplot call, like this first line, so I have ggplot parentheses, and then I have AES parentheses, what that's going to do is anything in here is going to get passed to all of the other geoms. So now for all of the other geoms, X is always going to be the time variable and Y is always going to be the weekly attendance variable. So now I don't have to repeat myself in geom line, and I don't have to re-specify X equals time, Y equals weekly attendance. It just inherits it from the top. So all of the AES values inside of the ggplot call, those get inherited later down, like further down in the other levels. And then within a geom call, these do not get inherited. And so now this group name, when it was up here inside of the call, you can see now it's going to get passed to all of them. And so that's going to draw several lines. That's drawing one line for each group level. So that's drawing one line for each team. But I didn't want that. I just wanted one for the overall division. So I had to only pass that to the line where I wanted one black line for each team. So I'll add that back in, and you can see it goes back to how it was before. And now down here, the color, so now I'm only using color to use the smoother. So now this is the smooth is it the smoother lines right here, these colored lines? And so now it's calculating for the whole division. It's smoothing across the whole division. And it's also still inheriting those X and the Y from the line before. So that's a really good question. There's a parameter, and I'm not sure like how okay or it is to use this, but there's this inherit.aes parameter. And if you set that to false, it will ignore the stuff from up here. So let's see if that, and yes, see now you see we got an error. Stat smooth requires the following missing aesthetics X and Y. So now if we get rid of that, there we go. Now it works again because now it's just inherited from the top. So again, I think it's best to put the ones that are most common to all the plots up here, and then that way you don't have to repeat yourself. There are some instances where I'm dealing with a lot of different data sets and I'm trying to stack a lot of different layers on top of each other, where I will just leave the ggplot call completely blank. I'll just leave it completely empty like that, and then I will insert the other information within each call. So now if I do this here, now it's just going to have the data. Oh, shoot. Anyway, so when I did that, now the data is not going to be inherited by geom smooth. And so now then it would throw an error saying, you know, geom smooth doesn't have data, or I don't know what exactly it would say, but it'll throw an error. Okay, let me look and see if there's any other questions being brought to my attention. Okay, I think that's everything. Okay, yeah, I think that's it for me. I don't see any other questions. So thanks again. Go crazy with all those resources. That's it. Follow me on Twitter at @sctyner. I'm gonna drop it. Or that's my GitHub handle and my LinkedIn thing too. That's me everywhere. So yeah, if you want to see more of my slides, you can go to my website. That's just sctyner.me. Thanks.